Hello everyone, this is Mr. Woolman. Today we're going to be talking about perpendicularity, understanding the concept of perpendicularity, how that will apply to proofs and algebra problems. First off, in perpendicular, the symbol there is what we will use in geometry to recognize what when we have perpendicular. It can be lines, rays, or segments that intersect, and they intersect forming right angles. These two lines, segments, intersect. That angle right there would be a right angle for perpendicular lines. In our first example, given those two segments AB and BC are perpendicular, what angles could we prove are right angles? Based off of the first given, we have segment AB and segment BC meeting and forming and are perpendicular. That would therefore mean that angle B is a right angle. Based off of the second given, saying that DC and BC meet together, we could say that angle C is a right angle. Those are the only two angles based off of the given information we could say are right angles. The next problem is an algebra problem based off of the two lines that are perpendicular AB and BC, meaning that this entire angle must be a right angle. And when we have two angles that are in a ratio of 3 to 2, we could put in 3x and 2x. And since those two angles are adjacent and they form a right angle, we could set up an algebra problem adding those two angles and setting it equal to 90. We could then solve for x and then make sure that we answer the question by finding the measure of angle ABD. We could plug in our x value of 18 in for 3x. Tells us that the measure of angle ABD is 54 degrees. When we are applying these two proofs, we have to make sure that we do not try to list too many things in one step. With our first given, or looking at the givens, we have two separate pairs of segments are perpendicular, and we need to say that angles are congruent. We need to think about just taking the first given statement. We are given that two segments are perpendicular. In our diagram, we are talking about these two lines or segments. Which would mean that this angle would be a right angle. And so we could say that angle SPO is a right angle, and our reason needs to be written in if-then form, starting off of our what we are given. We have two segments that are perpendicular. Okay, two segments are perpendicular, so that we can say that if we have two segments are perpendicular, they intersect, forming right angles. We want to prove that two angles are congruent, so we need to get them to be similar to each other. So going off of our next given, we have another pair of perpendicular lines that is again given. We could then say that a different angle is a right angle. Based off of this given, we have those two segments being perpendicular, so we have this angle is a right angle. That in our proof, angle UOP is a right angle. And we could just say this reason is the same as we used in number 2. Now in our proof, we have listed that two separate pairs of angles are right angles, which would allow us to say that the angles themselves are congruent. And we have used this reason before. If two angles are right, then they are congruent. The next proof is a little different because we are given, it's a little easier, because we are given that one of the angles is already a right angle. Our information with the given that FI is perpendicular to IS tells us that this angle must be a right angle. We first start with our given information. We can state the angle that is marked, angle I, is a right angle. Same reason we just used before. If two segments are perpendicular, then they intersect, forming right angles. We are already given another angle is a right angle, and that is given. And the same reason that we used in the last proof, we can state that the two angles are congruent, because if two angles are right, then they are congruent. I'd like you to use the two proofs that we just did to complete number 5. It's very similar to one of the proofs we just completed. And then complete number 6, which is an algebra problem based off of the algebra problem we just did with the ratio. Complete numbers 5 and 6. Come to class with those ready tomorrow, and we will discuss those at the beginning of class. And this concludes section on perpendicularity.